Let's see today selection rules for electronic transition. First one, Laporte orbital selection rule. It states that the electronic transition which involves a change in azimuthal quantum number are Laporte allowed. It has high absorbance, that is change in L is should be +1. For example, let's consider s orbital have two electrons. One of the electron will travel to the p orbital and hence delta L will be plus or minus 1. It should not be equal to 0. Second point, the transition within the given set of d orbital are forbidden. Generally d orbital, there are 5 d orbitals, subshells, and all have same L value, and hence delta L will be equal to 0. Hence dd transitions are Laporte forbidden. But there are some assumptions in Laporte orbital selection rule. Consider a complex where that metal ion will react with the ligand orbitals, and metal orbital have p and d orbital. This p and d orbital mix with each other, and hence now it's not pure dd transition. Mixing of p and d orbital occurs only in the complexes which do not possess center of symmetry. In the next slide, s orbital have two electrons. One electron will jump over the p orbital, and hence delta L equals to plus or minus 1. Let's see in the third. Consider a tetrahedral geometrical complex MnBr4 2 minus. Say a dot is shown over the Mn. It is the center of symmetry. For more information about the center of symmetry, see below. The center of symmetry or invergent center definition is given. That dot will travel to the Br at one point. Now, starting from the center, will travel in opposite direction with same distance. But as you know, it is tetrahedral geometry, Br will not present at that point, and hence this complex structure do not possess center of symmetry. Hence mixing of p and d orbital occurs and transition is not pure dd transition. Another example, since this complex, again we have shown a dot center of symmetry, it will travel to Cl, and at the same times equal and opposite direction it will reach to ammonia. Hence this molecule also, this complex structure also do not possess center of symmetry. Some mixing of p and d orbital will occur. Transition is not pure dd transition. Now a symmetric molecule, CO is surrounded by ammonia. This molecule possesses center of symmetry, and hence mixing of p and d orbital do not occur. Transition is pure dd transition, hence dd transition have delta L equals to 0, and hence transition is Laporte forbidden. Now another rule, spin selection rule. It states that during transition between energy level, an electron does not change its spin. Means we know electron have two spin motions, clockwise and anti-clockwise. While transition from one orbital to another orbital, that suppose electron is rotating in clockwise direction, then this clockwise direction should be maintained over the another level, higher level. An electron transition must not change the spin multiplicity of the system. For example, hexaaqua manganese, d orbital is singly occupied, that is d5. Hence, all d orbital have each electron, one electron. Hence, dd transition is spin forbidden, because from T2G to EG, electron will jump, but while doing this, it must follow the spin selection rule. Means the rotation, if in T2G orbital is clockwise, then while going to EG, clockwise direction rotation must be followed. And we know in each subshell, two electrons don't have same motions. That is, each electron have clockwise, then other must have anti-clockwise direction. Hence, this transition, that is delta S equals to 0, that is, this is the spin selection rule. Hence, therefore, many Mn2 plus complexes is colorless or pale, as given below in the diagram. In this slide, we have given T2G and EG orbital. See how the electron is jumping over the EG. Hence, dd transition is forbidden. And the last rule, that is third selection rule, is that simultaneous excitation of two or more electron is forbidden, as given below.